Hello everybody. Today we are going to see a reading from this Unit 7.5 Process Specification Tools. Processes in data flow diagrams represent required tasks that are performed by the system. These tasks are performed in accordance with business policies and procedures. Policy A policy is a set of rules that governs some task or function in the business. Policies consist of rules that can often be translated into computer programs. Systems analysts, along with representatives from the policy making organization, can accurately convey those rules to the computer programmer for programming purposes. Procedures put the policies into action. Policies are implemented by procedures. Procedures represent the executable instructions in a computer program. There are tools with the help of whom specification for policies can be created. They are decision table, decision tree, and software engineering notations. Decision tables. Decision table is very useful for specifying complex policies and decision making rules. Figure 7.5 depicts a decision table. The following are various components of a decision table. Condition stubs. This portion of table describes the conditions or factors that will affect the decision or policy making of the organization. Action stubs. This portion describes the possible policy, actions, or decisions in the form of statements. Rule. Rules describe which actions are to be taken under a specific combination of conditions. Decision tables use a standard format and handle combinations of conditions in a very concise manner. Decision table also provides technique for identifying policy incompleteness and contradictions. Rules. Here you can see figure 7.5 an example of decision table. Okay. Then comes decision trees. Decision tree is a diagram that represents conditions and actions sequentially and thus shows which conditions to consider first, and so on. It is also a method of showing the relationship between condition and permissible subsequent action. The diagram resembles branches on a tree. The root of the tree is the starting point of the decision sequence. The particular branch to be followed depends on the conditions that exist and decision that will be made. Progression from the left to right among a particular branch is the result of making a series of decisions. Following each decision point is the next set of decisions to be considered. The nodes of the tree thus represent conditions and indicate that a determination must be made about which condition exists before the next path can be chosen. Figure 7.6 depicts a decision tree. Here you can see an example decision tree for a customer bill payment system. Okay. Hope you understood it. Let's move. Structured English notation. It is a tool for describing process, and there are three valid constructs in this notation. They are a sequence of single declarative statements, the selection of one or more declarative statements based on a decision, example if then else, switch case, the repetition of one or more declarative statements, example looping constructs such as do while for do. The following are the guidelines usage of structured English notation. Avoid, avoid computer programming language verbs such a move, open or close. The statement used in the structured English notation should always specify the formula to be used. Structured English notation is based on the principles of structured programming. Process specification logic consists of a combination of sequences of one or more imperative sentences with decision and repetition constructs. Consider the following. Number 1. An imperative sentence usually consists of an imperative verb followed by the contents of one or more data stores on which the verb operates. For example, add person's salary to total salary. In imperative sentences, verbs such as process, handle, or operate should not be used. Verbs should define precise activities such as add or compute average, etc. Adjectives that have no precise meaning, such as some or few, should also not be used in imperative sentences because they cannot be used later to develop programs. Boolean and arithmetic operations can be used in imperative statements. Table 7.1 lists the arithmetic and Boolean operators. So here you can see arithmetic and Boolean operators. Okay, let's see arithmetic. Multiply, divide, add, subtract, exponentiate, Boolean, and or not, greater than, less than or equal to, greater than or equal to, equals to, not equal to. Okay, now comes structured English logic. Structured English uses certain keywords to group imperative sentences and define decision branches and iterations. These keywords are begin, end, repeat until, if then else, do while, for, case, etc. Grouping imperative sentences. Sequence construct. A sequence of imperative statements can be grouped by enclosing them with begin and end keywords. A decision selection. A structure which allows a choice between two groups of imperative sentences. The keyword if, then, and else are used in this structure. If a condition is true, then group 1 sentences are executed. If it is false, then group 2 sentences are executed. A structure which allows a choice between any number of groups of imperative sentences. The keywords case and of are used in this structure. The value of a variable is first computed. The group of sentences that are selected for execution depends on that value. Repetition. This structure shows two ways of specifying iterations in structured English. One way is to use the while do structure. Here the condition is tested before a set of sentences is processed. Alternative to while do is for structure. Repeat until structure. Here a group of sentences is executed first, then the condition is tested. So in this structure the group of sentences are executed at least once. Table 7.2 depicts the criteria to be used for deciding the notation among structured English, decision tables, and decision trees. Table 7.3 depicts the criteria to be used for for deciding the notation among decision tables and decision trees. So here we can see the criteria for deciding the notation to be used. Criteria determining condition and action, and transforming conditions and actions into sequence, checking, consistency and completedness. Table 7.3 Criteria for deciding the annotation to be used between decision tables and decision trees. Criteria portraying complex logic, best, worst, portraying simple problems, worst, best, making decisions, worst, best, more compact, best, worst, easier to manipulate, best, worse. So here we come to the end, and the answer of check your progress will be available in the description. Then we will see this data dictionary. A data dictionary consists of data about data. So here we see the data dictionary. A data dictionary consists of data about data. The major elements of data dictionary are data flows, data stores and processes. The data dictionary stores details and descriptions of these elements. It does not consist of actual data in the database, but DBMS cannot access data in database without accessing data dictionary. If analysts want to know the other names by which a data item is referenced in the system or where it is used in the system, they should be able to find the answers in properly developed data dictionary. Data dictionaries are hidden from users so that data in it is not tampered. Analysts use data dictionaries for the following reasons: to manage the detail in large systems, to communicate a common meaning for all system elements, to document the features of the system, to facilitate analysis of the details in order to evaluate characteristics and determine changes that should be made to the system, to locate errors and omissions in the system. The dictionary contains two types of descriptions for the data flowing through the systems: data elements and data structures. Data elements are grouped together to make up a data structure. Data elements are recorded in data dictionary at the fundamental data level. Each item is identified by a data name, description, alias, and length, and has specific values that are permissible for it in the system. A data structure is a set of data items that are related to one another and then collectively describe a component in the system. Data is arranged in accordance with one of the relationships, namely sequence, selection, iteration, and option relationship. Summary: design is the phase that precedes coding. All the components of system are designed logically. Then physical aspects of the system are designed. Form design, report design, database design, and program design, etc., are designed with the help of GUI controls, process modeling tools, data modeling tools, and process specification tools. These tools reduce the complexity of the design process. A data dictionary is data about data. These elements center around data and the way they are structured to meet user requirements and organization needs. So here we come to the end, and answers will be available in the description soon. So thank you. Till then, keep exploring.